Well, hiya folks, how you doing? Just thought we'd give a wee preamble to the video you're about to watch. This is Dan, Crazy Polish Man, who was helping obviously with the interviews, cameraman and whatever. So we just wanted to talk a wee bit about, the reactions that we're seeing from people and the interactions and how defensive and attack minded people are,
Yeah, it's unbelievable what we just experienced, because basically we were trying to talk to people like, some respect of, communication, like have a discussion about the topic, like, shape of the earth, and what we've experienced is just
it's like you can see it's almost like the media propaganda now is having an effect on people. So like, the girl that you're going to see in this video, I mean, she really marched. It's as if somebody had told her over there and she was coming to defeat us. So it's almost like they've made us objects within the media, and now people are just identifying us as targets. But for me, it's like a sign of their insecurity, where they feel as if they've got something to defend and they must come and defeat you, and that's what's being portrayed. I mean, at the end of the day, we can have these discussions between people, but if somebody wants to believe in a whatever aspect of reality or the earth, then that doesn't define me. I don't feel insecure. The reason why I'm approaching people is because, I think there's justification for us to have this discussion, and what I want to continually highlight is these types of responses that we get and why it's so defensive and so cult-like. It really is.
Yeah, like also, the thing is, well, at least we think that we should have a discussion. Let's have a discussion.
Yeah.
We don't have to convince anyone to anything.
No.
But now what we see is just a bad approach, like that attitude they have to defend some kind of thing, like it's that is culty behavior. It's really.
It's trying to always say to people, look, we're trying to have an objective discussion, but the topic is about the objective reality. So why do we?
No bias.
Exactly. But people are coming more and more with a bias.
Yeah.
And now you can really see it starting to come in, in places like Glasgow University. Well, the media and the propaganda is obviously having a knock-on effect, so that they're just identifying you as a target, and that you're somehow a threat to their worldview or their paradigm. Well, it's just not the case. What we're trying to highlight and talk about objective scientific inquiry. So there's nothing to defend, and when you see these behaviours, it really highlights, to me anyway, that we're dealing with some sort of cult belief. Regardless of whether the Earth could be proved to objectively be a sphere, the reasons for why people are believing in it are just empty, and they seem to want to defend it with their all, even though they don't fully understand why it is they believe it.
I would even say that the topic of that kind of discussion wasn't on the first place. They were trying to that was like ego kicking in and this kind of thing. So
you see, in particular, there's one chap here that we interviewed, and I really appreciate the guy for spending time speaking to me. But he's got a really pompous, demeanour. I'm looking at it and thinking this could be a future educator, because it's constantly trying to undermine and speak down to you as if you're just somehow daft, without ever listening to the nonsense that he's actually coming out with, and you're going to witness that here. I mean, that interview in particular was so bizarre.
Just unbelievable.
It's incredible. It's trying to reason with the irrational, unreasonable, as you will witness. But I just wanted to give a wee quick pretext to these interviews. And how we actually, viewed what was going on. Well, we're going to keep continuing it, and again, it's always trying to remain respectful. And there's even aspects and times in here where I'm getting annoyed, and you see it in my body language and my approach is, not always on point. This is something that you continually work on. But when you're dealing with zealot-like, encroaching, dismissive, and hubris, it's really difficult to keep your composure.
Especially when you see that communication breakdown is just something you cannot
no, and it's really difficult because you're having to go over these hurdles just to have the honest discussion with people, but you've got so many barriers to break down with them, and again, for me, this media approach of ridicule and propaganda plays a huge role in it.
presupposition, from everywhere.
Exactly. So, aye, I mean, it's interesting, and I'm sure that many people that have been asking this question and tried to have conversations could relate to certain aspects of this. So we tried a different approach today, rather than some of the methods before, but you'll see that as the video starts. So just thought we would add that in.
Yeah, that's it. Yeah.
Cheers.
Right.
Enjoy.
Cheers.
Recording. Checking if we've got the sound. So you can see that we've set up a wee sign here, a globe with a "Can you prove it?" and we're back at Glasgow University. So just another way to see if we can get people's attention, see if we can get them, trying to prove the globe Earth is. Should be interesting. See how it goes. Do you think it's flat? I'm here asking if anybody can prove if it's round.
I think it's square. You don't know what?
Well, my experience here is that it's level.
Aye.
My experience here is level. I can prove to you it's level. You can't prove to me it's round. Can you?
You've got to what the moon looks like, the sun, everything else on there. You get out.
See if I came to your house to measure your flare to fit a carpet, and I started looking at the light bulbs, you'd think I'd escaped to the mental institution. But here you are telling me to look at the moon to measure the Earth. Do you know that there's no measurable curvature? It's never been measured.
I'm sure I read about it, tell you what how big the moon was, the Earth was, miles right, didn't it?
The radius, the circumference of the Earth, say 24,000 miles.
That's
How did you get that?
There was no tape measure.
Did they?
There was no.
Exactly, Bill. This is the thing. What we're trying to highlight is we're showing that even the students here,
I think they've been lied to.
well, it's not that everybody's lying. Well, I believe that right up till I was 36 years old. So was I lying for 36 years? Or was I just like you? I just took it on face value that that's what was right what they were telling me.
I'm not changed it.
I went to try and prove it to myself.
Aye.
I couldn't. Everything that I found showed me that it was level.
There's a lot you can't prove, you just take it as the word, didn't you?
Right. There's certain things for me that I can look at, and that you can look at. But if I say to you right now, right, see when you get home, I want you to start studying water and its behaviour, right? And you'll find that water will always take the shape of the container that it's in. See the surface here, it's always flat, right? Always. We use it to build, we construct canals over hundreds of miles, and the whole shebang. You can't bend the surface of a body of water and make it stay bend, can you?
Goes level.
Exactly. But they're showing you a picture on the telly
That's right.
where it's round.
I know.
So what do you believe, the telly or what you can test?
I've never really thought of much into it, mate. Why are they lying is then?
Well, there could be all sorts of reasons. See, I could come up with so many reasons, right? But you know that the government's trying to control you, don't you? Right, so there's one motive. But also the problem is that you don't investigate the crime scene. You don't go looking for a motive before you've investigated the crime, do you? So that's secondary. We can get to that. But right now I'm asking the questions of this and why people believe it. So just as you say, you only believe it because you were told. But do you not think that's a bit gullible?
It is. That's the way people go through life, innit? The religion and everything.
That's, you see that as another religion. It's an air control mechanism. Because if you think you own that, you think there's no way off. And they're telling you that this stuff's millions and millions of miles away. So you're likely just to stay here and accept the life that you got. Do you know what I mean? What if there's more across?
Instead of shooting the stars.
So what if there's more across the life?
This is always greener.
You never know, do you?
You never know.
Never think about it, man.
Right, mate.
Sure, yeah.
Can you prove it?
Yeah.
Can I say to you though, like what I'm looking for is like something that applies to the natural sciences, so measurable, repeatable, demonstration, practicality. Like, would you be able to go for it?
Do you do any planetary watching? Do you do any observational astronomy?
Oh, I can look up at the sky and I can see luminaries up there, of course. Yep.
Have you looked at the motion of the planets through the night sky?
I've seen all that stuff.
Have you?
Yep.
Okay. have you tried to predict where they'll be in the future?
What do you mean?
So you look at where they were today,
Yep.
where they were yesterday,
Yep.
day before.
Oh, so you're talking
Try
about
to make
predictive
predictions of where
capabilities of a model you're talking about there?
Yeah.
So the celestial aspect, the celestial sphere is a mathematical interpretation that's been modelled, so they can use it to make predictions about celestial objects. What I'm asking people today is, can you...
No. But so it only works out, like, to be able to do predictions like that if the Earth is spherical, if it's travelling around the Sun, and that we are some kind of heliocentric kind of universe. Well, not universe, but the solar system works like that.
You understand that?
You ask for observable stuff.
Yep.
I mean, I'm telling you, you can see stuff move around us as if we are a body gravitating.
I'm not denying anything
attacked
that you're saying, but what I'm trying to highlight is that these are visible phenomena, so they're two-dimensional and they're interpretive. So we can only interpret what we think we see is going on.
This is everything you do. So everything you see with your eyes, you must interpret and you must try to
That's right.
think of some kind of way to explain it.
Yeah, because vision...
The best way to explain the motion of the planets in the sky and the sun and everything like this is from just assuming the simple case of where the Earth goes around the sun, and all the planets do as well, and you can see it. And you should try going out and bring a telescope and see where they are.
I have.
Yeah.
So I'm having a discussion. It's not a bias, so it's not a debate. I'm just trying to have because objectivity is all can all be discussed. So I don't have a bias and it's no defend and attack. So when we're talking about visible phenomena, we're talking about our eyes.
Yeah.
Our eyes are curved. So what we see through is spherical geometry. Right? These are curved, these are spheres. So when we're looking at things, we have to take into consideration that. What I'm asking people about is, if I want to measure this street right now, or an area of this floor, I'm looking for direct measurement of the floor. It's a red herring to be looking up here as a measurement of the floor.
It's very much not. I mean, how could you explain the motion of what we see with our eyes, planets through the sky?
Well, I can look at interpretations of that, but as I say,
the simplest model that you could come up with ever is going to be that we are going around the sun and that we are spherical.
There's been models through the ages that have been totally different to the heliocentric.
But they're all not as accurate
models.
And they have more assumptions. That's the crucial thing about. They have more assumptions than the simple model, which is just.
So this is what I'm trying to get the crux is the base assumption, and this is what I'm looking at. If I came to your home to measure your floor, okay, and I started to look at the light bulbs in the ceiling, you would think I had escaped from a mental institution because I'm interested in the floor. I'm not interested in what's going up here.
That's evading the point I'm making. That's completely evading. Because you asked
I'm not evading that.
Some observational. I mean, we can't just look at the ground and say and judge whether it's a sphere or whatnot from just looking straight down at our feet, because that's mathematically that's impossible. You're close enough zoom in enough to any sphere, you can approximate it to be a flat plane.
So what about the geometric applications then? We use Euclidean plane principles in every aspect of reality.
That's not true. We use spherical coordinate systems
for the sky.
For
for the Earth. For navigating by the stars, we use spherical stuff. For applications here on Earth, we use Euclidean plane principles. So from engineering, construction, and aspects of navigation, it's planar geometry that we assume. So that's telling me that this is a level surface that we're on here.
It's a good approximation, because you don't need to take into account the actual you don't need to take into account the curvature of the Earth in most circumstances. Everyday life is on what you might assume to be a flat plane, and that things work out easier that way. But if you talk about things that are affected by it, like I was saying.
So you're saying if me and you're engineers and we're going to build a bridge towards each other, like there's 10 miles between us, and we're using the Euclidean plane principles, you're going to tell me that we could just ignore the curvature of the Earth?
To be honest, I don't build bridges, but they probably do account for some degree. Likely do. I don't know.
I've never met an engineer that uses spherical geometry to construct anything.
They wouldn't use spherical geometry, but they might use corrections. They might account for things like every so often, like make some kind of systematic correction. I don't know if it's that.
Well, if I was to build my first starting point here, and I was to build my next block, so this is my starting point, which is plumbing level. Okay, so it's 90 degrees perfectly plumbing level. and I'm attaching my next section square to the first section, as I start to construct that out where it's perfectly level, the earth would have to be dipping away from beneath my point.
I know.
But in reality that doesn't happen.
It does. It's probably not to a degree where it matters. Even you're talking there.
Well, 8 inches over 1 mile is a fair bit to drop. That's a big margin that you have to be accounting for.
No,
That's only 1 mile.
Look, like I said, I'm not an engineer, but I don't know how if people even do corrections when you
But that's the honesty. This is what we're trying to get to the crux of, is just the honesty of people.
You came to me and asked me an initial question,
Yep.
and I did. I think I made quite a good
But
point.
what you have to
And,
understand
you
is,
haven't come explain to me why.
I've tried. But this is the problem with people, because I've got presuppositions about who I may be. What you've got to understand is I've spent the last 5 years extensively looking at this, and without any bias, I'm not a flat earther, a spherical earther, I'm none of these. I'm an objective investigator. So what I'm talking about is, I understand the concepts, the mathematical interpretations of the luminaries. So like in old navigation, your star charts were a rectangular sheet, okay? Now, from any given point that you start at, you're within your own sphere, do you understand? Because your vision works like this: the floor comes up, the sky comes down, and the walls converge inwards. So anywhere you move, you look as if you're in your own little dome. Now, using a form of calculus, you can pinpoint your zenith, so wherever you are in relations to the other stars. Now, when you move, you then look for your other 90 degrees, and by the angle of the arc of your eye, you can start to tell and pinpoint where you actually are. But when you're doing that, you're calibrating everything to the level. So when you use a sextant is calibrated to the horizon, and then you take your angle to whatever star or sun or moon that you're looking for. The triangles and sextants are plain geometric tools. They don't have curves. They're not accounting for curves anywhere. So the celestial sphere is a mathematical concept. It's not a tangible thing.
Yeah, you're right. The celestial sphere is a tool that people made hundreds of years ago to help navigate.
Yeah.
You're right.
Yeah.
But that doesn't take away from the fact that the observations that you see, and you use such things like the spherical sphere to help you predict to navigate and stuff, because there's a real physical thing behind it.
Yeah,
and
it's the physical thing that we're trying to establish. It's the here. This is the physical thing here. That up there's two-dimensional interpretations of visible phenomena, but here we're looking at the measurable aspects here. So,
right. So, I mean, back to what I was saying initially. I'm still not sure where your stance is on how you predict, say, like the motion of Mars in the sky. If you watch it, watch Mars in the sky.
Yeah.
It does this. It goes across the sky, double backs on itself, does a loop round, and then zooms off again.
Yeah.
And if you assume that this is just some projection, say from some celestial sphere, that's some 2D projection, the motion you cannot make a nice formulaic expression for the motion of it. It doesn't translate at all. But you end up with something very messy on paper. But if you just
what you're
assume
talking about, some interpretations that you saying don't work and don't
but
fit.
that's how everything, like, this is back to the start. Like, this is how everything works. You're talking there about how your eyes are curved and such. They're your tools for measuring things. It's all we've got. We only have our eyes that are the tools for doing the measurements, and we've got the data, things like the stars that we can measure to try and interpret. And it's up to us to come up with the best models to fit the data and such. And what you can do is you can look at the simplest model possible to try to predict what will happen. And the simplest, you heard of Occam's razor? Occam's razor is great.
Yeah, that's right.
Point. You can just say, well,
you're utilising Occam's razor, right? But you're making things so much more complicated. This is what I'm trying to point out. No. I'm trying to establish there. So here's Occam's razor. Here's natural, real science. Okay, natural phenomena. Well, I'll give you a natural phenomena. I can observe anywhere in this world that water has no form. That water runs downhill. Water will take up and fill any void. It'll fill the shape of that void, and the surface is always a horizontal plane 100% of the time. Testable, measurable, repeatable by every single person alive. That's a tangible fact. Bodies of water don't bend. Can they bend them? So we're surrounded by liquid everywhere. I mean, so that's a tangible fact. In relevance to
intangible
phenomena, because you can't get to these things in 3 dimensions.
You've made it as if like looking at stars is completely just devoid compared to looking at water. And I mean, I know water is closer to us, and it's, you know, we can go out and touch it, but it's still, you're still looking at something and observing it. You can't look at, you come actually to the same problem as well. Like you say there about whether water is always flat. It's not really the case. The water just settles to where the equilibrium is. And this takes into account the gravity.
The equilibrium is a flat line. But the most potential energetic state of a body of water is a flat horizontal line. To curve it and bend it would take an unfathomable amount of energy.
It depends on what your well is. If your well is doesn't
give me a demonstration for what you're talking about.
A demonstration.
Something that you as a human being can demonstrate to me to justify what you're saying. Because I can justify to you what I'm saying by practical reference. What you're saying is, you're telling me this, but you can't practically demonstrate that to me.
As in, you want me to go and get some water and curve it or something like that. I don't understand
that's the claim. That's the claim.
I mean, you made a claim as well. You said that all
Bad
water
claim
well
does.
well.
Bodies of water.
I mean,
That's the natural phenomena. You deny that would deny your own experience.
That's not true. That's not true at all. I mean,
if you want me to accept what you're saying,
it's the same premise to say that the Earth is flat and that water is flat. It's just like you're asking me to accept the premise that the Earth is flat before even going ahead with it.
No, I'm not asking you to accept anything.
If the Earth is not flat, then the water across it would be curved. You know, that's
circular reasoning. That's just circular reasoning.
No, but that's what I'm saying. The same way you asserted something, just as I asserted something.
But listen to what I'm saying. I'm following the scientific method of observing a natural phenomena, making a prediction, changing the variables.
No, but you said you asserted that water is always flat, and I'm saying no, that's not the case. And you say, well, but it's always observed to be the case, and I'm like, no, it's not. You, in that assertion,
so where are you observing it
that
at Disney? No, what I'm saying is I'm offering you what I've experienced, what I can test for myself, and what's applied in reality. But you're saying to me that it can be something different. So what I'm asking for is, where in reality would you offer me a practical reference to justify that?
Like if you zoomed out on it and you saw a body of water.
Back to visible again.
Yeah.
Just visible. See if we look up that street right now, and we see one of these trees, 200 metres up there. Can you measure it just by looking at it?
You can.
Go for it. Measure it for a minute.
I mean, you give me a protractor or something like that, and
unless you can move in it in 3 dimensions, how are you going to quantify it?
You can try your best with what you've got.
But it's not exacting.
That's the only thing you can do. You can only try your best with the tools that you've got, and you can come up with a model to try to explain the observations otherwise.
So what you're saying to me is, right, never mind your test of the physicality of the substance, just look at it.
That's what, no, but you're making it out, again, that there's something different between the observing that you do with the stars compared to, you say, you test, like, your fingers there, as if that's something different. But we are just looking at things.
But I can get to water in 3 dimensions.
So you can see it a bit clearer. You can get.
I can quantify it. You can
quantify it when it's far away as well. It's just not as well.
And then through my understanding, I can apply that to aspects of reality. So I can construct a canal. I can make foundations for a building perfectly levelled. I can use it for all sorts of practical applications, which tells me that that's a real world fact.
And just as well, because something in that situation might help you. You can't. Sorry, I'm still not too sure that where you're coming from with this point. Because you're saying just because you've got more information on something, because you can go out and see it closer.
What I'm trying to distinguish.
But you can't. What I'm confused about is that you say this about big bodies of water are flat.
It's really difficult with somebody like yourself because you're really emotionally invested in it, and I'm trying to remain really objective because I don't have a bias. So I'm just trying to discuss between you as a human being.
You do have some bias.
But if you looked at this, you would see how animated and encroaching you are. It's not a two-way conversation. You're taking a stance of defence and attack, like I'm an opposition to you. And all I'm trying to do is have a discussion to say, like, as human beings, how do we establish these things? So if we break it down, if we look at the sciences, right, do you know the subdivisions of science, or do you just think science is one umbrella? Let's just take it a wee bit at a time, see if we can get a bit of clarity. So if you can agree or disagree, the sciences have subdivisions. You have the natural sciences, the formal sciences, and the social sciences. Would you agree?
Yeah, whatever. Yeah, sure.
So the natural sciences is physics, chemistry, biology, that deals with real world tangible substance. Formal sciences is mathematics, logic, these types of things, because they're abstract, they're model based, they're interpretation based. And the social sciences, which is psychology, culture, people, yada yada yada. So when I'm talking about earth and reality, I'm looking at the natural sciences. Formal science, like language, like mathematics, does not qualify in part aspects of the natural sciences unless it's backed by the empirical aspect, the tangible three-dimensional stuff. Do you understand?
Wait. Yeah, again, you go back to tangible 3D stuff, and then done this with your fingers. Now, this is what I have a problem with. Like,
that's the natural sciences.
That's some.
The natural sciences don't deal with abstract, language. The natural sciences can only deal with reality and the substances and how they interact with each other.
Like, this is back to the star situation again. I mean, that is objective, empirical evidence you can see.
But the interpretations are not. The phenomena is real. The phenomena is it's not tangible. It's just visible. It's two-dimensional, visible. It's not tangible because you can't go up to them and move around them and understand them. You're interpreting what you think you see.
You can see them, and you can
can't see them. That's right. We're agreeing. This is what I'm trying to point out to you. That is two-dimensional. It's not three-dimensional.
That's an assumption as well. Just saying.
Can you get to them?
That doesn't matter. You're assuming they're 3D.
You see in two dimensions. You see 2D. The only way you understand three dimensions is where you can move around stuff.
You see something in it, you might perceive it as 2D. Doesn't mean that it's not 3D.
Of course. Because the difference is if you can only see something and it's only a two-dimensional representation, you can't fully understand it until you can move around it in three dimensions.
What would you say about that? It's a sphere. From your point of view,
that's a sphere.
That's a sphere.
Yeah.
It's not.
See, this is what we're trying to highlight. So unless you can physically move around that, you don't know what it is.
You have to assume that on the back of it, it's the same, side. It's a sphere, but it's not.
I'm not too sure the point that you're trying to get at. It's some kind of misleading.
No. I understand, visible phenomena. I understand the geometry that we apply to that because we're looking at it and it's two-dimensional. We have curved lenses on our eyes. So as I say, when you're looking along this street, you must be able to admit that the floor appears to rise to the centre of your field of view. It's not physically doing that. It's not ramping up. Your eyes are making that happen. But if I measure it engineering-wise, I can lay out a spirit level and I can establish whether it is actually level. So there's the difference of visible and tangible, because the measurement is real, but your vision is something totally different. We move around the world in three dimensions, we see it in two dimensions. So for me that's a fact.
I think I don't know the real point that you're trying to get at here. It's like you're saying that you can be disillusioned by some things, and this is true. Yeah. But you can try to explain things like the shape of the Earth, which you can't directly. You can't step back from it and spin it around and see it in 3D. You've got to.
So that's the
You've got to try if you want to say any strong conclusions about the shape of it. You have to, in that respect, go for what you call the non-tangible way of looking at it, because you can't directly, because this is why you're talking in the first place.
Deductively, exactly. But deductively,
so this is why I'm confused.
No, well, let me give you an example. Right. So if I understand the physicality of water and it collection into your body, right? When I go to somewhere like Loch Lomond, I understand Loch Lomond doesn't flow away anywhere. So I know from deductive reasoning and application and understanding of the substance that the start of Loch Lomond to the end of Loch Lomond is at the same elevation, a straight horizontal line, because that's how water behaves. Now if I was to try and look along Loch Lomond, what would happen is that Loch Lomond would appear to rise into the middle of my field of view, things would become obscured, and from that visible I could start to see, maybe that's dipping over a curve there, because I can't resolve anything. Do you understand what I mean?
Yeah, okay, right. So with your kind of reasoning, so you're saying like, what I've got in front of me, I can go around and examine it closely and I can understand everything about it. But you're assuming that then that if you don't go further away from it or something, or closer to it, that that the reasoning that you were able to piece together from this observation doesn't break down. You know, it's just like your understanding of the everyday world is, you might think it's tangible looking around and seeing all these 3D objects, and then when you zoom in very close and get down to like quantum kind of scale, then things start to look a bit messy. You're unable to associate the things that you see in the everyday to that scale. You know, it's
So
you can't apply.
So if I'm correct and I understand you correct, what you're saying to me is that, you know, obviously I've heard this before, that, you know, I can look at the body of water, I can understand that it's level from one point to the other, but if I could get out of the earth and see the earth, I would maybe see a curve. So my question to you would then be, because I'm looking for the reasoning processes of individuals, you've never been to space.
No, I've never been.
Have you ever seen the curve of the earth with your own eyes?
No, but I mean, that's you told me there that my eyes are curved, and I believe my eyes.
Well, so that because we can use other measurements to understand things,
And we do.
So, exactly. What was I going to say there? You know, you've never witnessed a curvature or anything with your eyes. So here's the thing, right? Do you know what the Earth curve calculator tells you the rate of curvature is? Have you ever looked at that? It'll tell you over 1 mile that it's 8 inches, and then it starts to square exponentially because it's an increasing curve. You understand that?
Sure.
So if I go to the west coast of Scotland and I can get two land masses with almost 30 miles between each other, the Earth curve calculator is telling me that there's a deviation of 350 feet between those 2 points. Now I can put a straight level edge up to that, I can have my horizon, the water between the 2 landmass points, put my straight edge up to it, and it doesn't decrease in elevation from one side to the other. So I'm looking for it, and I'm being told that it curves at this rate. They're showing me on my TV screen, then I'm going into reality to see if I can verify that, and when I go to reality, it's not there. So what I'm just trying to do is...
Have you ever seen satellites? That's a good one too.
Satellites?
Yeah, how do satellites work?
I don't know.
Don't know.
Well, you know, everything was done by triangulation beforehand. You know, I've got old books from Oxford University.
Not everything. We couldn't do everything.
Well,
before.
we could track aircraft going across the Atlantic, you know, back in the the early 1900s, when the aviation started to really increase. I've got a book from 1936 from Oxford University that talks about, you know, how they kept in contact with each other and how they mapped out the areas and stuff like that. It wasn't even, I mean, satellites only came into fruition when the science fiction writer Arthur C. Clarke invented them. But Arthur C. Clarke, the science fiction writer, is the guy that's credited to be a satellite. So if I go to Loch Lomond or I go into the hills, I lose the signal on my phone. You know, people lose signals in their drones. I don't know what somebody saying to me a satellite, what does that tell me about the Earth? I have to believe the TV.
Okay, I mean, whatever you believe in satellites, fair. And you know, if you're doing your own experiments and going to the rocks and measuring them and stuff, then and you find something that says against everyone's belief that the Earth is round, then good on you. Go and publish it. You know, that's
well, we're trying.
There.
I'm here all the time trying
but
to.
People don't, and because people do these experiments and they never work out.
Yeah.
And you know, I'm not discouraging. I'm saying that's a good thing to do.
Exactly.
But I mean, it all comes down to that things just seem flat on when you zoom into this, and you can assume a lot of it is the case. Like when
you're back to Occam's razor, your experiences is that it's flat. Everything tells you that it's flat.
Not everything.
What?
Like I was saying, the motion of the planets and such like that. What else? I guess weather, how the days work out. You know, these things just like they.
See what you're saying about emotions. I forgot about one aspect. So you're right. When I was saying to you about the visible thing in your own dome. See if we see an aircraft coming in the distance and we've got a clear shot of the horizon. See the aircraft, to us it appears to rise and arc over the top of us and then come down and go down another arc. Now that can happen in the space of half an hour. Do you think that the aeroplane's coming up over the curve of the Earth, arcing over the top of you and then going back down the other curve of the Earth at the other side?
No, it's just going over the...
Stay in elevation.
Almost,
your eyes.
You might as well assume that, because the distance probably travelled in that time is probably not hit much of a curve.
So what are you looking at then? Why does it appear to be level with your eyes and then appear to do an arc over the top of you? What causes that?
It's parallax.
Because of your eyes.
No, not because of your eyes. It's just the way the distances work out. Like,
It's going to be something to do with your eyes.
no. I mean, your eyes see it. It's just it's geometry. It's just that you are used to seeing things close by, and you're not used to seeing things so far away. It's like why.
But what geometry? What geometry?
Like you look down a railway track and you see
Yep.
that the railways
Convergence.
converge. Yeah.
Right, so what causes that?
It's parallax. I mean, it's just
But what's parallax? Geometry of what?
it's geometry of the
Vision.
light rays from it into
Vision.
your eyes.
Vision.
Yeah.
Right.
Well, your
So-
eyes collected, but it's actually from
But
the
the
source.
train
It's the
tracks
angle
never
from the
go
source.
like that. They stay
No,
like
no,
that.
no.
Right. So in physical reality, they're not doing that. So what's causing
It's
it?
not something wrong with your eyes.
None
It's
of us
some-
says it was something wrong with your eyes.
Yeah, but
It's an
not-
aspect of the eye. It's an aspect of vision.
No. It's not. That's not what it is.
So if it's not physically doing that, right, we know they're parallel for the whole distance.
Yeah.
They don't physically do that. So what is it that makes them appear to do that if it's not your eyes?
It's the distance and it's the distance from you. The distance is getting further away. Obviously, the further the track goes down the line.
Yeah.
And for that reason, it appears to converge. Like,
Appears
yeah.
by your
Yes.
eye. Because it's your eyes that are the
Your
that are
eyes,
the-
your eyes are just collecting these straight rays of light from the
Yeah.
track. It's not that they're distorting the rays.
Yep.
They're just collecting it.
So it's like that, an angle like this.
No, but it's not to do with that. It's not to do with that at all. It's a distance phenomenon.
A distance phenomena. So just distance
geometric
makes things
phenomena.
appear.
Yeah.
But the geometric phenomena is your eyeball. Because that's what you're looking through.
No. Have a look at
I
parallax.
don't understand what you're saying here.
No, have a look at parallax. It's not.
I know what parallax is. Parallax is, you know, parallax is like if we were looking here at this branch, right, see the one above that pole here, right? And then if I go down like that,
Yeah,
now
it doesn't-
it appears to be lower than the pole, that's parallax.
Exactly. So it's the angles from the light rays there, the angles and the distances that have just made this happen. It's geometric.
I'm not changing my distance, that's parallax. What I'm saying is if I use that pole as my starting point,
Yeah. So
the
if
tree
you
appears
imagine
higher.
if you imagine one angle there to be one like railway track, and
Yeah.
then you look down, you've moved the distance between the two railway
Yeah.
tracks, and you look again.
Yeah.
It looks like things have kind of
Looks
converged but
because
it's
of the
not.
geometry of your eye.
No. Here, sorry.
Two different points of observation.
Yeah.
That's what it
Different
is.
points of
Two different
observation.
points of
Yeah.
observation.
Yeah, but it can equally be you're looking at from the same observational
Yeah.
point and two different points in
Yeah.
space, and they can appear to converge.
You keep saying it, I don't know why you're denying it, appear to converge, because that's how your eyes are working.
No, it's not.
Well-
I'm sorry, I must go.
Just
It's-
quick, just to clarify it, right, we've got two railway tracks like this, and they're 10 miles long, right, you're standing in the middle looking at it, and they appear to do that. Physically,
I mean,
the
if you
distance
got-
stays the same.
if you had like a
Let's just
instead-
finish the point.
No, but if you had instead not your eye, but just like some detector that just detects light from it and
An
did the
optical
same
device?
thing. Any optical device, yeah, and then it's going to detect the same thing. It's not. If you change, what I'm saying is, if you change the shape of your eye, you're still gonna change the shape of your eye, and you can still see. Then you're still gonna have the same phenomenon. It's nothing to do with the shape of your eye. It's to do with the geometry of the system itself.
What system, the train tracks are the same distance?
Yeah. But they're
But
the same distance apart. But you're as you're looking, the distance from yourself is changing. Obviously, the further you look down the track. So because of that, they converge.
Yeah.
I know it seems
Through the eye?
counterintuitive. Right. Okay. I'm sorry. I must go because we're
No
going-
worries, my man.
Have a look
Right.
at parallax and do
I know, I understand it.
and do some observational kind of stuff. Look at a telescope and try and look at the planets. It's
You're
fascinating.
honest,
It's
listen.
fascinating, and like also you will see that it just makes sense. Like you
Can I say something to you? I just want to be candid and honest with you. There's a bit of hubris coming from you, and what I'm going to say to you is that if some of the things you say here are absolutely ridiculous, And you're saying to me is that I need to go and look at these things. I think you need to understand these things.
No. Right, tell me
You
what's
need to-
ridiculous. I don't want to be here too much.
Because you can't understand the separation of visible phenomena and tangible phenomena. It's like you're being contrarian for the sake of it because you've got some sort of bias, but you're asserting that it's not a property of the eyes that things converge when it is a property of the eyes because physically they don't converge.
No, they don't. No, but they appear to. It's just
To
a
what
distance
your
thing.
eyes appear to what?
No.
Well, you've said the word
yeah.
appear. No, appear to what?
They could appear
Your
to
eyes.
any observational thing you're using.
What?
It's not
An
it's not
optical
to do-
device
when
that's
you
based
say-
on the eye.
When you say your eyes, I'm assuming that you mean it's because of the shape of your eyes.
It's a
Is that what
property
you
of
mean?
vision.
It's not. It's you don't need spherical eyes to observe this. You could use some just photon detector, photodiode kind of thing, and just place it there and measure the light that's coming from these objects, and you'll see the same phenomenon. It's not because of your eyes. It's just a geometric thing. You'll have to look up.
Right. You've said appears and you're saying geometric thing. And now where's the geometry? Is it out here?
Yes, yeah, not the geometry of the measuring device, but the geometry of the thing you're
So the train
observing.
tracks are doing that then? Because that's
No.
the geometry would have to be there.
So you're getting mixed up the geometry of the train tracks. The train tracks are straight.
Yes.
The geometry is the light rays coming from the train tracks and going to the observer, the measuring device. Okay.
Yes.
So that's where the geometry.
So to the
occurs.
measuring device it appears that they're converging.
Yes, but it's not because of the measuring device. It's because of the system.
I don't.
I'm sorry.
I can't reason with that because it's
Parallax
absolutely
is
incredibly
perplexing
daft.
and it takes a lot of time, a lot of thinking to understand as well. Sorry, but it
No
does.
worries, my man. You take care
Thank
of
you.
yourself. You take
Thanks for
care
your
of
time.
yourself.
Thanks
Have a
very
good
much.
day, and,
Cheers.
Yeah, my man. Cheers. Can you believe it as a globe?
Yeah, it is.
Can you prove it then? How would you scientifically prove that the Earth was a globe?
There is a center of the globe, you know?
Yeah, but that's an assumption. How would you prove that it was curved, that it was a globe in the first place?
It's a globe, yeah.
Yeah, but not as plastic.
Yeah,
The
yeah, you
model-
mean, yeah, of course, yeah.
Right.
Because there is two pools.
Two poles.
Yeah.
But how does that give you measurable curvature?
So if there is two pools, you can go from one to another,
Yeah.
then that means it's a pool. It looks like a pool.
So there's two poles there. I can go from one to the other. Does that mean that this is curved?
Yeah, but there is a lot of options and see. So how you can go directly from this one to another one.
Have you ever seen bending bodies of water?
Yeah,
Where?
the oceans. So you can realize that
Physics tells me that that's impossible.
this is possible or impossible.
But physics tells me that
Yeah.
bending water is impossible.
Possible, yeah.
Because that's what I demonstrate, that's what I measure, that's what I test. So that's scientific method, testing, observing, test,
Observing.
repeat. But we see this on the TV and we think that this is reality because of the TV screen. So I'm
All
asking,
right. So
what
you
I'm
mean
asking-
that this is? So you mean that they're trying to convince us that this is a
Well,
globe?
what I'm asking people is if you believe that the Earth is a globe, what science could you point to
All right.
justify that belief? Do
You
have-
mean that there's a need for evidences to prove that?
Well, not so much evidence, some measurable proof. Like
Measurable.
if I want to build this fence, I can use tools and I can measure it and I can lay it out and I can construct it. So that's proper measurement.
You mean that this is not tangible?
Yeah, it's not a tangible thing.
Yeah.
It's a mathematical concept.
Rather
and we
than
see an image on the TV screen, but there is no scientific measurable proof that we have a curve there.
Okay. That's interesting.
So that's what we're trying to highlight. We're just asking the questions and
Yeah.
the reasoning for why people believe what they believe, and we're just trying to document that and highlight it. So, do you believe it's a globe?
So forget about any previous knowledge.
Well, what knowledge do you have? What's your experience of the Earth? Do you experience a curve anywhere? Have you ever seen a curve?
Uh,
If I ask you about the horizon,
Horizon,
how
yeah.
would you describe the horizon to me? How would you describe that?
Describe them. Yeah.
Would you say it's a straight, flat line?
Yeah. If you are talking about horizon, yeah, you would see a line.
Flat line.
Yeah.
So that's your human experience. The only reason that you think it's anything other than level is because what they show you on TV. And you've only ever seen this in your life, plastic.
Yeah, plastic globe. Yeah.
So if I asked you to make me a real scaled down model of the globe of the Earth with a rock and water on it, would you be able to make that?
Yeah.
You couldn't make it, could you?
You cannot. Yeah.
The water would just fall off and lie flat again.
It's interesting. Good luck.
Thank you. Cheers for speaking.
Thank you.
Thank you.
Nice to meet you.
Thank you. Yes. Plates can move. It doesn't define the shape of the Earth.
Yes, it does.
How? Explain.
Because you've got some expanding, some subducting, so the Earth would either be expanding, subducting, it wouldn't be able to stay the
So
same
how does that determine the geometry or the shape of the Earth?
The shape of the plates is the Earth, they're on the surface.
But the shape of the plates are flat,
No, they're not.
and they're intersecting like this and moving under each other and pushing each other up and down.
Yeah, but how would that work on a flat disk?
Who says it's a flat disc?
What do you say it is then?
See, this is a perfectly highlight the straw man propaganda that the mainstream media put out about people who investigate these things. Because you're regurgitating straw man propaganda about flat discs. I've not even asserted a flat disc.
Well, what do you think it is then?
It's level. Demonstrably level.
It's flat.
Demonstrably
What
level.
shape?
Level.
Shape.
My experience,
Flat
what I
has to
can
have a shape.
prove, what I can prove to you is that it's level. The outer parameters of it, I don't know what it is.
You don't know what shape it is. Okay, well, if it's flat, how you have some subducting, some it would have to expand.
I'm going to get to these, but can I ask you, can we look a wee bit at the psychology and the behaviour and why you're so triggered? Well, you're very defensive and very attack, defend orientated. I don't know what that's about. But here's the thing, if we're talking about the objective world, it's unemotional, it doesn't care about your bias or my biases or whatever, so why would we bring emotion into it? Well, it seems like you are to me. So, you're going on about plate tectonics. What about the geometric assumption that we utilise in practical engineering, construction, navigation? We use Euclidean plane principles.
Yeah,
What
the
about...
scale, that's what matters at the scale you're working at. Once you get to a much larger scale, it will eventually.
That's just word salad. That's word salad. So we
Scale is
utilise
very important when you're
Euclidean
thinking
plane
about
principles don't work on curved surfaces. Fact.
Okay.
Bodies of water do not bend. Fact. We use water to construct and level in every
At
aspect
the scale
of living.
of the size of the planet.
Again, you're just using word salad to justify your belief in your
So you
circular
have the
reasoning.
scale of the planet.
That's
the
presupposition.
scales that we work at are much smaller. Okay, so the error caused by the curve is small enough that you can just ignore it.
So it's
Same
not
thing
really there
with-
then. So it's just like saying it's
No,
not there.
it's so big that at the scale you don't see it. But when you get to scales like when you're working in space travel and
You're
things like
using
that.
words. You're like a religious
How else-
person trying to justify to me your
You're saying
belief in
I'm
an
using
invisible sky,
words.
Daddy.
How else would you like me to
Hey, do you know,
explain
man?
the concept for you?
All right. I'm not interested in concepts. I don't care about formal language. I'm interested in
You're
actual.
actually university. What are you
Na-
expecting?
but do you understand the separation of the sciences? Do you know what the sciences are?
Yes.
What?
I'm a geology student.
List them for me.
Sciences is it's
What's the three categories?
look at these biology, chemistry, physics.
They're the natural sciences that deal with substance, the stuff that I'm interested in. What you're talking about some normal sciences, language, mathematics, logic.
How would you explain the sciences without using words?
What do you mean?
Well, you're saying you're interested in the natural sciences.
The natural world was
but
here.
you don't want to think about
Listen,
language.
let me explain to you.
How do you explain it without
The
it?
natural world was here before words were invented. Right, so I don't need
You
words.
don't need to explain that to me in a geology.
I don't need words. I need practical
To
reference.
explain them, you do need words.
I don't need an explanation.
You don't need an explanation
No.
on why you're here.
Because this is what I'm trying to say to you. In order for me to accept some aspect of objective reality, words are not required. What's required is practical reference.
Practical reference.
Practical reference.
How do
and
you
that's
explain
it.
the reference?
What do you mean? How do you explain it?
Well, you're saying you don't want words. You look at things, but
Do I-
you
do I
use
need-
words
do-
to explain.
So if I'm trying to build a house right, just imagine I'm building my house right, and I go, do you know what? I need to make sure this is level. Without using words, I'm going to get this substance.
Well, we're
I'm gonna-
back to scale again.
Well, listen, I'm going to
Scale
fill
of a house versus
I'm
scale
going to
of
fill
a
it with
plant.
water, right? And that water's going to show me whether I've got my foundations level. Where's the requirement for
How
words?
big is your house? How big is your house?
That's-
100 metres square?
But you're going to complicate it by your language, your sophistry. Because you're going to assert to me that at some unspecified scale, the physical property changes and it can now adapt.
It's not the point that the properties changes, it's just the effects are so small that we can just ignore them. If you want to find the effects, you can look at it, but it's
So
tiny
what
scale.
that basically equates to is that something's real, but it's so minute that we can just ignore it and it's not really there. That's crazy.
Well, if you think about when you get an X-ray, okay, so you're being exposed to radiation.
I know you're going to use a
but-
misrepresentation and jump to some other aspect. Stick to the world and the actual reality.
I'm explaining what, right, so this is a physical property that we know radiation damages cells, but when you get an X-ray, it's such a small amount of radiation that they just ignore it. It averages out to nothing. If you get lots and lots and lots of X-rays over a larger scale, then you get sick, but if you have one X-ray, averages out to nothing.
If I'm using Euclidean plane principles and I construct something over the span of 10 miles, there's over 100 feet of margin of curvature there. That's not something I can just ignore.
No, but that's what you're saying. You're saying the scale of a house, nothing.
So what about when we build bridges?
They do take that into account.
No, they don't.
Yes, they do.
They're using Euclidean plane principles. They're not using spherical geometry to construct. They're using Euclidean plane principles.
Okay, what about other things? So I'm not an engineer, don't know a huge amount of engineering. I'm an engineer and a geologist, my area of expertise. So how about when you have stratigraphic sequences, you can see clear changes in climate. How would that work on a flat plane? How would your climate change? So we explain it by Milankovitch cycles, which we can understand. We've observed through the rock
That's got
record.
nothing to do with defining the shape of the Earth.
Yes, it does. It wouldn't happen on a flat plane.
How?
Because
That's your assertion.
Michael,
What you're doing using constantly circular reasoning, you've got this presuppositional
No,
bias,
so, right, that's-
and you constantly just try to reaffirm it by making statements that are just empty. Right? You're saying to me about tectonic plates doesn't define the shape of the Earth. Things move, right? Fine. How does that tell me anything about the shape of the Earth? Can you
You're
measure
working
the
on
Earth's
that
shape
plane.
for me by tectonic plates? You can't.
okay, how about measuring? So would you agree with the concept of like some inner core, outer core, mantle? No.
Oh, I see cartoons.
This is cartoons. What about seismic surveys?
What about seismic surveys? How far do they go down?
Really far.
How
So
far?
the way
What's the biggest hole they've ever done?
biggest hole is the
Polar.
one in the Polar Peninsula.
How deep is it?
Inside
8 miles.
8 miles. Okay.
How far is it from the crust to the centre of your globe? Thousands. Right, so by
6,000
digging a hole 8 miles, you're
Okay, but
moving
we're not saying digging a hole, we're saying seismic surveys. So if you have an earthquake at one point, you can see from seismometers all over the earth, all over the globe.
But see the
So you
instruments.
can detect an earthquake at one point
See the
on
instruments
the
you're
other side.
using.
Yes.
They'll utilise X and Y, Cartesian grids. Right? Do you know what a Cartesian grid is? A horizontal and a vertical that intersect at 90 degrees. And it's a box grid, and then you've got your graphs and stuff all within it. Again, you're utilising Euclidean plane principles. When you're looking at these graphs, they're not on a curved surface, they're on a flat horizontal plane.
I'm not giving up though.
Come back and see us.